Q4876. Which instruments should be used to make a pitch correction when you have deviated from your assigned altitude? A. Altimeter and VSI. B. Manifold pressure gauge and VSI. C. Attitude indicator, altimeter, and VSI. The correct answer is C. Attitude indicator. The attitude indicator provides information about the aircraft's pitch attitude relative to the horizon. By referring to the attitude indicator, the pilot can determine whether the aircraft is pitched up or down and make the necessary pitch corrections to return to the desired altitude. Altimeter. The altimeter measures the altitude of the aircraft above a given reference point, typically mean sea level. When a deviation from the assigned altitude occurs, the pilot can refer to the altimeter to determine the extent of the deviation. By comparing the indicated altitude with the assigned altitude, the pilot can gauge the pitch adjustment required to regain the correct altitude. Vertical speed indicator, VSI. The VSI provides information about the rate of climb or descent of the aircraft. It indicates whether the aircraft is ascending or descending and at what rate. When a deviation from the assigned altitude happens, the VSI can help the pilot assess the trend of the altitude change. By monitoring the VSI, the pilot can make the necessary pitch corrections to return to the assigned altitude smoothly. By utilizing the information provided by the attitude indicator, altimeter, and VSI, the pilot can effectively assess the aircraft's pitch attitude and altitude deviation and make the appropriate pitch corrections to return to the assigned altitude. These instruments work together to provide a comprehensive picture of the aircraft's pitch and altitude state, enabling the pilot to maintain precise control over the aircraft's vertical profile. 4878-2. During standard rate turns, which instrument is considered primary for bank? A. Heading indicator. B. Turn and slip indicator or turn coordinator. C. Attitude indicator. The correct answer is B. During standard rate turns, maintaining a specific bank angle is crucial for consistent and coordinated maneuvering. The primary instrument for monitoring and adjusting the bank angle is the turn and slip indicator or turn coordinator. Turn and slip indicator or turn coordinator. These instruments provide information about the aircraft's rate of turn and coordination. They typically feature a needle or ball that indicates the rate of turn and a slip/skid indicator. By referencing the turn and slip indicator or turn coordinator, the pilot can maintain a standard rate of turn, typically defined as 3 degrees per second, which ensures smooth and coordinated turns. The turn and slip indicator or turn coordinator helps the pilot visually assess and control the bank angle during standard rate turns. By keeping the needle centered and the ball centered within the slip/skid indicator, the pilot can maintain a consistent bank angle throughout the turn. 4882. Prior to starting an engine, you should check the turn and slip indicator to determine if the A. Needle indication properly corresponds to the angle of the wings or rotors with the horizon. B. Needle is approximately centered and the tube is full of fluid. C. Ball will move freely from one end of the tube to the other when the aircraft is rocked. The correct answer is B. The turn and slip indicator, also known as the turn coordinator, is an instrument that provides information about the rate of turn and coordination of the aircraft. Before starting the engine, it is important to ensure that the turn coordinator is functioning correctly. Checking for a centered needle and a full tube of fluid helps verify its proper operation. Needle centered. The turn coordinator typically has a needle that indicates the rate of turn. Prior to starting the engine, the pilot should observe the turn coordinator and ensure that the needle is approximately centered. A centered needle indicates that the instrument is in a neutral position and not indicating any pre-existing rate of turn. Tube full of fluid. The turn coordinator contains a tube filled with fluid that helps the instrument respond to changes in the aircraft's movement. Before starting the engine, it is important to visually inspect the turn coordinator and ensure that the tube is full of fluid. A full tube ensures that the instrument is properly calibrated and capable of accurately indicating the rate of turn and coordination during flight. By checking for a sintered needle and a full tube of fluid in the turn coordinator prior to starting the engine, the pilot can confirm that the instrument is in a neutral position and functioning correctly. This helps ensure the reliability and accuracy of the turn coordinator during subsequent flight operations. 4883. What indications should you observe on the turn-in slip indicator during taxi? A. The ball moves freely opposite the turn, and the needle deflects in the direction of the turn. B. The needle deflects in the direction of the turn, but the ball remains centered. C. The ball deflects opposite the turn, but the needle remains centered. The correct answer is A. The turn-in slip indicator, also known as the turn coordinator, is an instrument that provides information about the rate of turn and coordination of the aircraft. During taxiing, the pilot can observe specific indications on the turn coordinator to ensure proper coordination and control. The ball moves freely opposite the turn. The turn coordinator includes a small ball that indicates the coordination of the aircraft. During taxiing, when making a turn, the ball should move freely in the opposite direction of the turn. For example, if the aircraft is turning to the left, the ball should move to the right within its housing. This movement indicates that the aircraft is properly coordinated, and the pilot is applying the correct rudder input to counteract the side forces generated during the turn. The needle deflects in the direction of the turn. Additionally, during taxiing, when making a turn, the needle on the turn coordinator should deflect in the direction of the turn. For example, if the aircraft is turning to the left, the needle should deflect to the left as well. This deflection indicates that the aircraft is indeed turning and provides the pilot with a visual reference of the rate of turn. By observing these indications, the ball moving freely opposite the turn and the needle deflecting in the direction of the turn, on the turn-in slip indicator during taxi, the pilot can ensure that the aircraft is properly coordinated and turning as intended. This helps maintain control and stability during ground operations. 4899. Conditions that determine the pitch attitude required to maintain level flight are A. Airspeed, air density, wing design, and angle of attack. B. Flight path, wind velocity, and angle of attack. C. Relative wind, pressure altitude, and vertical lift component. The correct answer is A. Airspeed. The airspeed of the aircraft directly affects the lift generated by the wings. To maintain level flight, the pitch attitude needs to be adjusted to achieve the appropriate balance between lift and weight. Higher airspeeds require a lower pitch attitude, while lower airspeeds require a higher pitch attitude to maintain level flight. Air density. The density of the air also affects the lift generated by the wings. In denser air, the wings can generate more lift, requiring a lower pitch attitude to maintain level flight. Conversely, in less dense air, the wings generate less lift, necessitating a higher pitch attitude to maintain level flight. Wing design. The design of the wings, including their shape, size, and airfoil profile, influences the lift characteristics of the aircraft. Different wing designs have varying lift coefficients, which determine the pitch attitude required to maintain level flight at a given airspeed and air density. Angle of attack. The angle of attack refers to the angle between the wing's chord line and the oncoming airflow. It directly affects the lift generated by the wings. To maintain level flight, the pitch attitude needs to be adjusted to maintain an appropriate angle of attack. If the angle of attack is too low, the wings may not generate sufficient lift, requiring a higher pitch attitude. Conversely, if the angle of attack is too high, the wings may generate excessive drag, necessitating a lower pitch attitude. By considering these factors, airspeed, air density, wing design, and angle of attack, the pilot can determine the appropriate pitch attitude required to maintain level flight. Adjusting the pitch attitude based on these conditions allows the aircraft to balance the forces of lift, weight, thrust, and drag, ensuring a stable and controlled flight.